Right, so we've moved into Code Assist to do the PLC program part of it. Right now, I'm just going to get stuck into the code at the moment, okay? I'm just looking at the ladder logic and how we set it up. As we go through it, I'm going to show you different ways of simulating your results and testing out your code and your system. So there's going to be some things that differ at the moment. So don't worry about it too much. Okay, we're just going to worry about the code for the first aspect. Now, all I've done is I've created a global variable list. Okay, so I've added that into my application. So if you go to your application, you right click on it and go add object, you get an option for GVL, global variable list. Okay, so I've already added that in, and I've just set up my inputs and my outputs according to my wiring diagram. Now, just what a GVL is basically, it allows us to use these variable names across multiple maybe programs or subroutines or different things that we need them for. So it's a good habit to get into at the moment. It'll become a bit more relevant later on, but for the moment I've just put them in. Okay, so if we look at just what I've added in, I haven't added any address tags or anything for the hard wiring because we're just looking at simulation for the moment. And again, this can change depending on what way you want to test your results, so just bear with me for the moment. But basically, we've all our inputs, so our start button, our A0 sensor, or A1 sensor, when sensor tell us when B is retracted, B1 and being extended, and then we've our outputs. Okay, remember we're doing the relays indirectly, so that's just basically taken from the wiring diagram. Okay, you don't need to worry about this part because that's just hard wiring. This is just what we're looking at, what's going into the PLC, what's coming out of it. Okay, so they're my inputs, they're my outputs. So I've set them up within it. Okay, so they're just booleans, so they're going to be either on or off. Then the other thing what we're doing is we're using this position variable store. It's like a data location for us to store information. And what that's going to do for us is it's basically going to tell us which number are we in our sequence. Okay, so it's just, think about it as a box that we're just storing information, and what we're going to be storing in it is integer values, whole numbers. Okay, so these whole numbers are what's going in, and this will help us keep our code sequential, help us move to the next step, and it also lets us keep track of where are we in our sequence. What step number are we at. So if we do run into a problem, we can actually look and see, fault find troubleshoot that bit easier, because we'll know where we got stuck. So that's just a bit on the setup, right? Don't worry too much about it because depending on what way you're going to simulate it, it can be different. Okay. So what I want to do is I want to just get into the code. Now, sorry, I don't need them there anymore because I've got them in the global variable list. Okay. So we'll hop into the code, right? Now, what I always start with is I actually start with my outputs because this literally tells me which step numbers are going to trigger my outputs at what time. Okay, so what I'm going to do is very easily, right? I'm just going to roughly put together some lines of code, okay, that look at my outputs. Right, so remember, I've got LED D, okay? Now, if I put this in here like this, see that it asks me to, initialize, it says, where is that? Well, because I've stored it, I haven't put it in up here, I've stored it in the GVL, I've got to actually type in GVL, then do decimal point, and then it gives me that list of variables that I have there, inputs and outputs. So that's where it's stored, right? Now what I'm just going to do is I'm just going to set up my output. So I know I had LED D, and then I had C, and then we also had A extend for my outputs, and then we had K1 and K2, didn't we? So I'm just going to pop them in for the moment. Okay, K1 and K2. So I'm just looking at the outputs at the moment according to my wiring diagram. So they're all my outputs. And the other thing I want to do is I want to look at them and I want to see, well, is there anything unusual with my outputs that I need to consider? Well, because this is a spring return, I've only got one output that I can control. So when I need to move this forward, I need to latch this on to make it go forward, and then break the latch to make it come back. With this type of a valve, I only need to, give it a pulse at the output going forward, and it'll move forward for me. Okay, there's nothing springing it back. So when I keep that in mind, I will just kind of spot that early, and I will bring in my latch just so that I have that going from the start. So I know I'm going to need to latch this on. And then I also know from my LEDs, they're going to need to latch on, because if I just pulse my LEDs, well, I'll never actually see them coming on. So sorry, that's my K1, K2. I'll not need them because they're grand with a pulse. But up here, I will need to bring in my latches. So I'm just setting up the outputs at the start, just making sure that everything's going to be alright. Okay, so hopefully you understand from the way the outputs are that I'll need these to latch on, I'll not need these to latch. Okay. So now I want to say, well, when are these going to get triggered? And this is already done. We've done all the hard work here by writing it out. Okay, so we know it's step 10, B needs to come on, that LED needs to come on. And then in step 380, it needs to come off. Right? Now, what we could do is, we could literally try and write out the whole thing and, test does it work for the first time. And that's unlikely, and especially when we've 38 steps, it's unlikely that we're just going to write everything out all well and good first time. So what I'm actually going to do is I'm just going to break it into those 3 sections that it's kind of naturally broken into, and I'm going to deal with coding this first, testing it, and then moving on from there. Okay, so this is what I'm dealing with at the moment. So we're just going to focus on this top part. Okay, so just this part. So as I said, all the hard work's done. It's telling us when we should be activating each output. So if we just look at D should just come on in step 10. D isn't referenced anywhere else there. So how do we get that to trigger? Well, we've got to do some of our comparator commands. Okay, so here we're using some comparators, and they'll be under maths, and we're going to say equal to. So I'm going to pop this in here. I can delete out that input, and basically I'm going to say, right, at step 10, and we're saying, if number 10 is in that position variable. So if we've moved for at step 10 in our sequence, turn on LED. Okay, so at step 10, that LED should come on. At step 20, we should turn on LED number C, or letter C. Put that in there, copy and paste, number 20, and you can delete that. So you're starting to see how nice and easy this is. Right, now look at A. A comes forward in step 30, and it also comes forward in step 70. So 30 and 70 needs to go in there. So put that down here, pop in 30, and we got to do an OR. Okay, so you need to get that kind of parallel context set up. Delete that there. Sorry, I made a wee mess of that. Let me just go back, delete that first, and make it a bit neater. Notice this is a wee bit awkward with that. Delete this. There we go. So what do we say? 30 and 70. Yeah, so 30 and 70, it needs to go forward. Right? Now, if we want to just deal with A at the moment, right, when does A come back? Remember, we got to break the latch to make A come back. So A must come back in step 60 and step 100. So 60 and 100. So how we break the latch is we use the not equal to symbol. So not equal to. And again, we're just checking this position variable. And sorry, what I say? I said 100 and 60. It's supposed to come back. So 60 and 100. There's my outputs. Okay, then we look at K1. So remember, K1 is making B go forward. So B going forward, so it goes forward in step 40. and step 80. Okay, so 40 and 80. So then we just copy these down. So 40, then make a parallel contact below it, 40 and 80, and then we can delete those. So we're just using the step numbers to trigger the outputs. Okay, and then again, when does it come back? It comes back at 50 and 90. Okay, so 50 and 90 for it to come back. And pop that down there. 50 and then 90 below. And then I can get rid of this. So now I've got my output set up, okay, and it's literally as easy as that. Okay, it's all the hard work was done here for me. Just have to make sure I type in them numbers correctly and trigger my outputs. I suppose the other key thing is making sure which needs to latch on and which don't. Okay, and I'm just checking, are we in step 30? If we are, make A extend. A will latch on, and if we get into step 60 or step 100, it will break the latch. Okay, so that's how we use our step numbers to trigger our outputs, and that's kind of the easier part. Now we've got to look at generating those step numbers from our inputs. Okay, and we'll look at that now down below in the code.